Okay, what if I told you that everything you think is solid, the chair you're sitting on, your own body, isn't actually made of tiny solid things at all? Yeah, that is the absolutely mind-bending reality that quantum field theory reveals. And today, we're going to dive in and unravel what it means for, well, everything.
So picture the smallest possible thing you can imagine, like an electron or a quark. What pops into your head? If you're anything like me, you're probably picturing a tiny solid dot, right? A little speck of stuff. It's an image that's been baked into our brains since our very first science class.
Yep, exactly. We see them as these impossibly tiny billiard balls just zipping around in empty space. It's simple, it's neat, and you know what? For a really long time, it seemed to make perfect sense. But here's the kicker. That picture? It's just fundamentally wrong. Reality, as modern physics has shown us, is something so much stranger, way more connected, and honestly, a lot more beautiful. All right, so where did this nice, simple picture of ours fall apart? Well, this wasn't some sudden change of heart. Physicists were forced to let go of that tiny dot idea because the universe itself started screaming at them that it was wrong. So on one hand, you've got our gut feeling. A particle is one thing in one place. Simple. But on the other hand, experiment after experiment showed that a single electron could act like a spread out wave. I mean, it would create interference patterns, just like ripples in a pond. So how can a tiny dot be in many places at once? The answer is, it can't. And that one single paradox just completely shattered the old way of thinking.
Now, to solve this seemingly impossible puzzle, physics had to basically tear down its old foundation and build a brand new one from scratch. And this new idea? It shifts our focus away from the things in space and puts it onto space itself. And that radical idea is the field.
So, what is a field exactly? Well, you can think of it as a property of space itself. Just imagine there's a value, say temperature or pressure, at every single point in a room. That whole setup, that's a field. And we're actually already familiar with them, like the gravitational field that's keeping you in your seat right now, or the magnetic field that makes the compass point north.
Okay, and this is where quantum field theory takes that idea and just runs with it to the absolute extreme. QFT says there isn't just a gravity field or a magnetic field. No, it says there is a field for every single fundamental particle, an electron field, a photon field, a quark field, all of them filling every single point in the universe, all overlapping, all coexisting in the very same space, right here, right now.
Which, of course, brings us to the biggest question of all. I mean, if the universe is really just made of all these invisible fields, then what in the world is a particle? Seriously, just think about that for a second. If the electron field is literally everywhere, then what is this specific little thing that we call an electron? And here it is, the answer, the central, mind-blowing truth of QFT. A particle isn't a thing, it's an event. It's a ripple, a tiny, concentrated vibration in its underlying field. Think of the field like a perfectly calm ocean stretching out to infinity. A particle? That's just a little wave that pops up on the surface.
And this is so crucial. A particle's properties, its mass, its charge, they aren't features of some tiny ball of stuff. No, they are characteristics of the vibration itself. Its mass, its charge, its spin, all of these are just descriptions of how that underlying field is vibrating right at that point.
And get this new way of looking at things doesn't just redefine matter, it completely changes how we see forces, interactions, and even the very nature of what we call empty space. So how do particles interact with each other? Well, it's actually pretty simple. Fields interact with other fields. A vibration in the electron field, which we see as an electron, can cause a vibration in the photon field that it's connected to. And what do we see? We see that electron spitting out a photon, a particle of light. That's it. All forces are just fields talking to each other through these vibrations. This leads to one of the absolute wildest ideas in all of physics. So what happens if you take a patch of space and somehow remove all the particles, all the vibrations? Is it truly completely empty? The answer is a hard no. The fields themselves, they're still there. And because of quantum uncertainty, they can never be perfectly still. They're constantly humming with these tiny fluctuations of energy. This is what we call zero-point energy, and it means that empty space is actually a roiling sea of potential.
Probably the most famous example of a field shaping our reality is the Higgs field, right? This thing permeates the entire universe, and as other particles try to move through it, they interact with it. It's kind of like trying to move through molasses or thick honey. Some particles really struggle, they interact a lot, and that's what gives them their mass. Others, like photons, just zip right through without interacting at all, and that's why they're massless.
And look, this isn't just some abstract theory. In 2012, physicists at CERN actually found it. They discovered the Higgs boson, which is nothing more than the particle, that localized vibration of the Higgs field. And its discovery was a massive, stunning confirmation of this entire way of looking at the universe.
Okay, so reality at its most fundamental level is made of fields. Got it. But that still leaves us with one final and maybe the most important question of all.
If everything is just fields, why does the world look like it's made of solid, separate objects? Why do we experience a world of little particles and not a universe of wavy, interconnected fields? How do we connect this bizarre quantum reality with the solid world we can actually touch and see? Well, the answer, it turns out, lies in the act of observation itself. When one of our instruments, or even our own senses, interacts with a field, it can't perceive the whole spread-out wave. Instead, that interaction forces all the energy of that vibration to kind of collapse into a single point-like event. It's like we poke the field, and the field pokes back at one specific spot. And that's the particle we detect. So it really all comes down to this. Reality is structured as a web of continuous fields, but it's experienced as a collection of individual particles. The structure is fields, the experience is particles. So let's just recap real quick. The universe isn't made of things, it's made of invisible fields. What we call particles are just little vibrations in those fields. And all of reality, I mean matter, forces, you name it, is just the result of these fields interacting with each other.
I mean, it is a complete, total shift in how we see existence. And it leaves us with one last, pretty profound question to chew on. If every single atom in your body is really just a complex pattern of vibrations rippling through a dozen different quantum fields, then what does that make us?